Hi, so let's go to the lab 3 question 1. Given n switches, you are required to create a mesh topology, which is to ensure that every switch has been connected with each other. Then you need to write a recursive method to return the total number of connections required for n switches. So given 4, the result is 6, given 7, the result is 21. So let's dive into the first case, 4 switches. So this is how the 4 switches return 6 results. So have a look here. Let's say given 4 switches, you want to connect it to everyone, right? So 0, first of all, 0 will be connected to 1, then 0 to 2, 0 to 3. Then after this, second iteration, 1 will be connected to 2, 1 will be connected to 3. And lastly, 2 will be connected to 3. So by doing that, you get the result, which is 6. Same goes to the case where you have 7 switches. You can try yourself. So the code is very easy. Have a look here. Now you have the public method, a public static method, which calls itself recursively. So every recursion method, it will requires one, if not more than one, stopping condition. This stopping condition indicates that, if let's say if the parameter of n is less than or equals to a certain number, then we need to return the constant value. So in this case, our stopping condition is if it's less than or equals to 1, I will return at 0. It means we don't require any more connections already if we have only one switch. Else, I will do this recursive function, which at first I will get an n minus 1. So as you can see, the calculate connections, let's say for the case where at first the I is 4, the n is 4. So n is 4, I will have 3 times, right? If, let's say, this is when n is 4, I will go for 0, 1, 0, 2, 0, 3. This one is uh, n is 4, n is 4, n is 4, this is n is 3, n is 3, then this is n is 2. So when n is 4, I have 3 times. When n is 3, it means this one I already solved. Then when n is 3, I have 2 times. When n is 2, I have 1 time. And n equals to 0 or equals to 1, I will just return a 0. It doesn't count as a connection. So at first, it will have, we will put a 4 inside. Then 4 minus 1 will be 3. Right? 3, then we calculate again, or n minus 1. So the next iteration, the next recursion, we will have n equals to 3. Then n equals to 3 will be plus with the 2. Then we'll plus with the 1 until the n is less than or equals 1. Then we return a 0. So to better explain the recursion function, let's look at this scenario. When n equals to 4, the return result, I will be returning 3 plus the function call, and inside is 3. Then function 3 will return 2 plus function 2. Then this one, function 2, I will return 1 plus function 1. And lastly, the function 1 will return at 0. So after I return all these functions, I will replace the return result to the function. So this is 0, and this one will become function 2, and the entire thing will become function 3. So at last, we will get return 3 plus 2 plus 1 plus 0, which is equal to 4. No, 6. Okay. So, yeah, you'll get the result after all this recursion has been completed. So we can test run, see if the result is same as 6 and 21. That is correct. Well, recursion is not an easy thing to think of the logic. So that's why I always recommend to use a looping, to use an iteration whenever you can. Unless recursion really solves your problem, like very efficiently or with a very minimal amount of code. Else you can use a iteration, you can use a simple looping to solve the questions actually. Yeah. If you can use a iteration, don't use a recursion. Well, to think of the logic of recursion, you need more practice and you to try to get used to the nature of recursion, which the nature is no yet returning the end result. So for example, at first it's 4, right? So 4 plus calculate connections is no yet return the end result yet. It will go until the very bottommost when the n equals to 1, then only it will return back the result to the first calculate connections call you have. Well, if you have any problems, then feel free to raise the issue. We can discuss together. Yeah.